Hi everyone, welcome to the CodeQueryHub. In this video, we will continue our discussions on subqueries in SQL. So in the previous video, we understood the self-contained subqueries. Now we will focus on inline subqueries and correlated subqueries. So let's start with the inline subqueries. So inline subqueries are written in from clause, and basically we use the result of one table as a temporary table and use it in another query for further calculation. So let's understand with the help of example. Let's select our database first. So let's try to work on the orders DB and let's make it active first. So let's see our data set first. So for that, we are having the basic select query as select all from table name, select all from table name, that is table order as A. Just select it and execute it. So yes, this is our data set and we are having reference number, order date, customer name, category, product, sales and profit. And there are total 22 rows inside this data set. Now let's try to understand the inline subquery. Let's take an example. Suppose we want to count the customer whose total sales is above the overall average sales. So find the count of customers whose total sales is above the overall average sales. So how to approach this problem? First of all, let's select those columns which is needed to answer this question. So we need sales column and customer details. So let me take reference number and the customer name. And we need the customer wise total sales. So we are having the aggregated function sum and let's apply over e dot sales and we take it as total sales. Now there are non-aggregated columns and aggregated column in the select statement. So let's write the non-aggregated columns inside the group by clause. So let me write it as group by this one. So yes. So this is the customer wise total sales. Now we need to have the filter on the total sales whose total sales is greater than the overall average sales. So how we did it? So this is the aggregated column and to have the filter on the aggregated column, we are having we can do it with the help of having clause. So let's use the having clause. Having sum of sales is greater than, and let me write it as select average of sales from table name is TBL order. So let's select it and execute it. So yes, you can see there are 11 customers whose total sales is above the overall average sales. But we need to have the count, means a single digit, which will represent the count of customers. So how to do it? Let's take this table as the temporary table and write in the form of subquery as select all from and from this table, and let me write the table name as T. If we select it and execute it, we will get the same table. Now we need to find the count of, let's take the reference number as count of customers. So just select it and execute it. So you can see that there are 11 customers whose total sales is above the overall average sales. In this way, you can use the inline subqueries to find this type of questions. Now let's take another example. Let me select the database. So yes. And let's take another. Now suppose we want to have the second highest selling product in accordance with the sales. How do we find it? Let's see. Suppose we want to get the second highest selling product in terms of sales. So for that, we need product column and the sales column. So let's select these columns. So let me copy this. And let's select the required columns, that is product and sales. Now, as we can see that products are repeating, so let's group them. So we are having the aggregated function sum to have the product wise sales. So let me write it as product wise sales, total sales, you can say. And since we are having non-aggregated and aggregated column in the select statement, so let me write it in group by clauses product. So just select it and execute it. You can see you are having the product wise total sales. Now you need the second highest selling product. So for that, you must arrange the products in the order of sales. So let me sort them. For sorting, we are having the order by clause. So order by product wise sales in the descending order. So let's select it and execute it. So you can see, so binders and machines are the top two selling products in terms of sales. But what you need machines as the output. So how to do it? Let's first select the top two products. Just select it and execute it. So yes. Now you can't do anything further in this table. So let's take this table as the temporary table and select all from this table. And let's name this as T. Just select it and execute it. So yes. Now let's sort it again so that the machine come first. So order by total sales, or we can say product wise sales. So yes. Now we can select the top one product from this one. So finally we got the product, which is the second highest selling product. So in this way, we can find out the second highest or the fourth highest, fifth highest product accordingly. So first select the those many products from the temporary table and then arrange them in again in the ascending order and then find the required number of products. So this is the use case of inline subquery. Now let's understand the correlated subquery. So let's take the database first. So let's work on subquery DB to understand the correlated subquery. So let's make it active. And we are having these tables. So let's understand the structure of the databases. So for that, We are having select top one star from customers. And another table name is select top one star from customer location. Just selected and executed. So yes, we can see this is the customer table and this is the customer location. And this is customer ID, first name, last name, date of birth, phone number, and email ID. And this is the customer's house ID, address, city, country, and customer ID. And we're having common column as customer ID in both the tables. So let's first understand what is meant by the correlated subquery. So it depends upon the outer query. So we can say it cannot run independently and it is used in where and having loss. So let's see the example. Suppose we want to get the customer details. Let me write it as suppose we want to get the customer details whose name starts with K and country name is, let me see what country names are available here. Let's take the San Diego. So country name is San Diego. So let's try to find it out. Just select it to see the structure. So let's start doing it. So select all from table 1, that is customers. Let me write it as A. Where? So let's try to find out the customer IDs from this table where the country name is San Diego. Okay. Let's match those IDs and return in the outer query. So for that, let's take this customer in. Let's write the subquery as select. Let's take the second table, select all from table 2, that is customer location, where, and let's give the name as B, where B dot country equal to San Diego. And what else we need? We need the customer name starts with K. And we can see the customer name is present, first name is present in the customers table. So we can write it as and A dot first name, that is F name first. And since we have to find the customer name for those customers whose name starts with K, it can be anyone. So we need to do the pattern mapping. So for pattern mapping, we are having the like operator. So like K, and we can use the modulus operator for 0 or more characters. And we have to match the customer IDs, no? So let's not return everything, just return the B dot customer ID. So customer ID HSP. Just select it and execute it. So yes, there is one customer whose first name starts with K and whose country is San Diego. But if you notice that inside this subquery, it cannot be run independently because it is referring to the table which is present in the outer table. And it is also referring to the table which is inside the subquery. So because of this dependency, this becomes a correlated subquery, because if we try to execute it, it cannot run because it depends upon the outer subquery. So that's the reason it is not preferred in the practical scenario. Now let's try to write it with the help of self-contained subquery. Self-contained subquery. So how will we write it with the help of that? So let's say select all from customers as A, where, let me see the structure. Yes. Now let me filter first. Filter the name first here, and then whatever we need from the table to, then we can write it in the subquery. So where A dot F name, like sin, and we have to match those customer IDs whose country name is San Diego. So we can write it as E dot cust ID in, and let me write the subquery as select all from second table, that is customer location, as B, where what we need from this table, we need the country. So B dot country, just see, equal to San Diego. San Diego. And let's try to return the customer ID. So B dot cust ID. Just see. Now let's try to execute it. So yes, the same output. So this is more efficient because it is referring to the independent query. So let's execute it. So yes, these are the IDs whose country name is this, and we are matching these customer IDs with these one in the first table. So it is more efficient, and we use the self-contained queries in the practical scenarios. And one more thing to be noted here is that, let me write it as, so you can see that the subquery cannot be run independently, and first it will filter down these records with these records row by row. So it is more slower. So we can see correlated subqueries can be slower because they run multiple. So that's why in real scenario, we try to optimize or avoid them. So if it is possible to have the solution with the help of self-contained query, so then prefer using the self-contained query. So yeah, this is the discussion based on the inline subqueries and the correlated subqueries. So the subquery topics is over. So that's it for this video. If you found this video helpful, don't forget to like, share, and subscribe to CodeQueryHub. Thanks for watching.